Now, you know that we have already studied one thing, which is probability mass function, which is PMF. Okay? Which means that probability mass function is basically a probability distribution, which means it tells you for every value of x, what is your px. I mean, px equal to, some people write it small x, some people write it k, whatever you want, you can write. Okay, let me write k. I mean, you can write anything. Which means if x is 1, then I mean it can take any value. It is not necessary to take positive value. -5, let's suppose, then 1, maybe 3, anything. Okay, if x is like this, then what are the probabilities? This is called probability mass function, which means it tells you that for every x, what is the probability, what is the mass that is sitting at this point, what is the mass that is sitting at this point, what is the mass that is sitting at this point. This is called probability mass function. There is another function that is called cumulative distribution function, or CDF. CDF is defined like this, that if you want to calculate a probability, let's suppose probability that x is less than or equal to some number, maybe k or some number, okay, k or maybe 5 or 3, then you can say that it is same as, let's suppose x can take the value which is 1, 2, 3, 4. Okay, let's suppose x can take 4 values. So if I'm saying that x can take less than or equal to 3, it is same as saying that x can take either 1 or 2 or 3. Basically, it is cumulative, which means it will sum all the probability masses till this point. Okay, it will sum up all the probability masses till this point. Let's just have an example and then you will be more comfortable. Okay, just 1 second, give me 1 second. Okay, so now they are saying find the cumulative distribution function of the total of heads obtained in 4 tosses of a balanced coin. Which means, let's suppose there is a balanced coin, function of total of heads obtained in the 4 tosses. Okay, if you're tossing it 4 times, then what are the possible values that x can take? X is number of heads, number of heads in 4 tosses. What do you think? What are the possible values that x can take? I think it can take 0 if there is no head, maybe 1 head, maybe 2 head, maybe 3 head, maybe 4 heads, right? It can take these many values. Everyone agree with this? X is number of heads in 4 tosses. 4 tosses means if you toss it 4 times, then how many heads you can get? Maybe 0, maybe 1, maybe 2, maybe like this, right? Okay. Can you write the PMF first? Because you need to actually write the PMF to write the CDF. So there are two things. One is PMF, one is CDF. Okay, so you have to calculate the PMF to calculate the CDF. So let me calculate the PMF. So to get 0 tosses, 0 heads, how many, what is the probability that you get 0 heads? This is only one case, which is tail, right? So what is the probability of this? I think 1 by 2 power 4. So this is 1 by 2 power 4. Now you get 1 head. What is the probability? Can anyone tell me? What is the probability that out of 4 tosses you get 1 head? Okay, the one engine is right. Anyone else? How you are calculating? Okay, 4C1. Okay. So basically, you just need 1 head out of 4 tosses. Now that head, the interesting part is that head can be here, that 1 head could be here, 1 head could be here, 1 head could be here, 1 head could be here. Which means there are 4 possibilities that are leading to 1 head. Which means this could be the case. This could be the case. Okay, this is tail. This could be the case. Sorry. Or this could be the case. Since there are 4 possibilities and each of them is having 1 by 2 power 4, so that's why I need to multiply with this 4, or I need to sum all of these four probabilities, which means 4 into 1 by 2 power 4. Because there are 4 different sequences that are leading to my desired thing. So you can say 4C1, okay? Because I mean, instead of listing out all of this, you can say 4C1. It will come under the Bernoulli distribution. I will teach you the Bernoulli distribution in tomorrow's class. It will, like by that time, you will be, after the Bernoulli distribution, you will be more comfortable. And this is actually following a Bernoulli distribution. it is actually as good as saying the number of successes. I mean, number of successes in n trials. You just need one success. So you can define your own success. It is basically success is here getting ahead. Okay. So number of heads or number of successes in n trials is just 4 CR. I mean, sorry, NCR into P power R into 1 minus P power R. You might have seen this formula earlier also, but this is called Bernoulli distribution. We will see the Bernoulli distribution in tomorrow's class. For now, I'm just trying to make you understand that since there are four possibilities, that's why you will be having 4C1. Okay. Because every possibility is having 1 by 2 power 4, which is equally likely. And since there are four sequences, that's why 4C1 into 1 by 2 power 4. Okay. Now, you get two heads. What is the possibility that you get two heads? What is the probability? Probability will be you have two places to choose, right? If you want two heads, you have two places to choose. So see here, you have two places to choose for head, two places for tails. You can do one of them. I mean, either you can choose for head or you can choose for tail. It will be 4C2 into 1 by 2 power 4. Are you getting this 4C2 thing? See, there are four places. In those four places, you can put head either here. I mean, you can choose two positions, and there are 4C2 total sequences that are having. There are 4C2 total sequences that are having two heads. That has two heads. So there are 4C2 total sequences, and one sequence is having, what is the probability of one sequence? It is 1 by 2 power 4. So that's why the answer is 4C2 into 1 by 2 power 4. Suppose if I ask you that what is the probability that you get this? What is the probability that you get this? Then what will you answer? These are the two heads. See, I'm asking specifically that you get head and then tail, then head, then tail, which is 1 by 2 power 4. Because everything is independent, and then you will say 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. So this is 1 by 2 power 4. Because I'm asking you specifically that you should be getting head, then tail, then head, then tail. This is 1 by 2 power 4. And then similarly, if I ask you what is the probability for this, then you will say again 1 by 2 power 4, right? Because I'm asking you specifically that this is head, tail, tail. But if I say that two heads, if I do not tell you a specific sequence, which is head, tail, tail, head, tail, or whatever, right? If I just say that two heads, probability of two heads. Then you need to take all of them into encounter. Basically, if I just give you a specific sequence, then it is okay. I mean, there will be no 4C2, 4C1, there will be nothing like this, okay? Because I'm giving you a specific sequence. If I do not give you a specific sequence, then you have to take all the sequence into encounter. Then you will count all the sequence which are coming out to be 4C2, and every sequence is having this probability. So that's why you will say this is 1 by 2 power 4. Okay? I hope I'm able to convince you. So this is 4C2 into 1 by 2 power 4. And now this will be 4C3 into 1 by 2 power 4. This will be 4C4 into 1 by 2 power 4. So if you simplify, this is 4 into 1 by 2 power 4. This is 4C2 means 6, right? 6 into 1 by 2 power 4. This is again 4C1, which is same as 4 into 1 by 2 power 4. And this is 1 by 2 power 4. Okay. Okay. Now KS is asking, is it not 4C2 by 2? Okay, let's just see. Why do you think this is 4C2 by 2? Okay, you want to divide, you want to say that it's head is not permutable like this, right? I think you are mixing two concepts if I'm not wrong. So maybe if you want to, I mean, there is no overcounting. See, this is the division method is for overcounting. Once you overcount and then you divide it to equalize it, right? That's what we do. So let's just try using that method. Let's just say head, tail, tail. Then you can say it is 4 factorial upon 2 factorial into 2 factorial. This is also one of the method, right? Which means it will be 4 into 3 upon 2. I mean, into 2 factorial into 2, it will get cancelled out. This will be again 6. Right? You can do in this way also, which is 4 factorial are total factorials and upon 2 factorial into 2 factorial. 2 factorial for head, 2 factorial for tail. I mean, this 4 factorial is overcounting, which means if you permute these 4 numbers, then 4 factorial will be the answer. But there is, let's suppose there is no other way to overcount. Then once you overcount, then how to normalize it? we need to divide by the overcounted numbers. So we have overcounted this head-head permutation. We have overcounted for every head-head permutation. We have overcounted the tail-tail permutations. That's why we need to divide with 2 factorial into 2 factorial. That's why finally the answer will be 6 only. Okay. So maybe this 4C2 by 2, I'm not sure that how you're getting. See, the division is for overcounting only. Okay. So just maybe just think about it that this in this 4C2 you are not overcounting anything. You are just choosing the 4C2 or the ways to choose 2 places. This is not the permutation. I mean, this is not you are not permuting head. Basically, these are the 2 places. In these 2 places, whatever you like to put. Okay, I'm not even asking you that what you want to put in these two places. Whatever you like to put. Let's suppose if I just ask you that just choose those 2 places, then you will say that okay, let me choose in 4C2 ways. Then let's suppose if I say that okay, like in those 2 places you are going to put head, then you will say that yeah, 4C2 ways only. I mean, I'm not sure if I'm able to explain. Actually, I'm not in touch with the combinatorics, so my explanation might not be relevant for you. I mean, you might think that this is not in line with the course because I'm not touch with the combinatorics and I'm just using my intuition. So let's suppose that 4C2 are the ways where I'm choosing the 2 places. Now this is into, I will not divide, okay? I will just multiply with this and into the number of ways that you are putting the quantity. If you are putting head, then how many ways you can put head? You can put just in one way, right? It is head only. But suppose if I give you those 4 places, I ask you to choose those four places, just choose 2 places. You can choose in 4C2 ways. And then if I tell you that you can put head tail, and how many ways you can put this head tail? You can put in 2 ways, right? So this will be 4C2 into 2, in fact, right? So it will be in fact multiplication. The division, I'm not sure that how you're dividing. HS tail. Okay. So now you are giving me the possibilities. So you are saying that HS tail, S tail, TH. Okay. You are saying there is no other possibility. Are you sure? Tail, HS, right? This is one more possibility. Maybe you can just list down all the 6 possibilities, right? I mean, you missed out some of the possibilities. You can just list down all the possibilities. Okay. So anyway, let's come to this. Now, what we wanted to calculate this CDF. Okay, PMF is clear to everyone, right? So for PMF, we will be getting this. Now, how to calculate the CDF? Let me write the PMF once again. So PMF was this, that for X value could be, the possible X values could be 0, 1, 2, 3, 4. Okay. For 0, I think it is 1 upon 2 power 4. Simply. For this, it was 4C1 into 1 upon 2 power 4, which means 4 into 1 upon 2 power 4. It was 4C2 into this, which means 6 into 1 upon 2 power 4. It was 4C3, which is again 4 into 1 upon 2 power 4. It was again 4C0, which is just 1, which is 1 upon 2 power 4. Okay. So this is your PMF. Now, can you calculate the CDF? CDF means that you need to calculate for every value of X, you need to calculate this F, which means that you will say that what is the probability that, I mean, that F of 1. So this quantity is basically F of 1. This is F of 2. This is F of 3. This is F of 4. F of 0, 1. Okay. F of 0, 1, 2, 3. This is 0. This is 1. This is 2. This is 3. This is 4. F of 4. Now, this will be P of 0 only. Right? I mean, generally it is P of less than equal to 0. In general, you can say it is P of X less than equal to 0. And since there is only one possibility for X less than equal to 0, it is just P of 0, P of X equal to 0 basically, right? And here it will be P of X less than equal to 1. And now in this case, it will be P0 plus P1, P0 plus P1. Similarly, you can find out these, which means this F1, if you want to find out, this F1 will be 1 by 16 plus 4 into 1 by 16. Okay. Now F2 will be, can you write the F2 here? let me just write the F2 also. So F2 will be, you can write the F2, which will be 1 by 16, 1 by 16 plus 4 into 1 by 16 plus 6 into 1 by 16. Okay, this will be F2. Similarly, you can find F3 and F4. That's not very tough. ठीक है, ये आ गया समझ? See here, this is F0, which is just P0. F1 is, I mean, in general, what is the F0? F0 is P of X less than equal to 0. But in this case, P of X less than equal to 0 is just P of X equal to 0. So that's how we are calculating F0, F1, F2, F3. Okay? So these are the answers. These are the real answers. Now, let's just observe the CDF. I mean, what it is doing. Basically, the CDF, observe that this distribution function is defined only for the value taken on by the given random variable. Is not, okay, defined not only for the, okay, which means that if I just ask you, let's suppose, if I ask you, can you calculate me F of 10? Then what will your answer? Can you calculate me F of 10? Can you tell me F of 10? It is P of X less than equal to 10, which means this is P of X less than equal to 4, because less than equal to 10 here is just less than equal to 4, right? In this case, because the only possible values are this, which is just F4, which is this, right? So F10 and F4 are equal. That's okay. I mean, that's not a problem. That's okay to me. Okay. But the thing is that it is even non-zero. It is even non-zero for the things which are which the random variable cannot take. Which means this F10 is basically F4, and if you sum all this probability, then you will observe that it is 1 basically, because these are the only four things that are possible. It is 1. Which means after a certain point, after F4, it will be 1 only. F5 will be 1, F6 will be like this. If I just ask you what is F of 2.5, then what you will say? It is P of X less than equal to 2.5, which means that X less than equal to 2.5 in this case is just X less than equal to 2, right? P of X less than equal to 2, which means it is just P of F of 2. F of 2.5, if you observe F of 2.5, it's coming out to be F of 2. That is okay, right? Because this is X less than equal to 2.5, which is same as X less than equal to 2. So basically, you have the non-zero for F2, F2.5 also. But if you ask me what is the probability of 2.5, then it is, can anyone tell me what is this probability? This is 0, because because my random variable cannot take this value. That's why it is 0. But what is the CDF for 2.5? It is just F2. It is non-zero. Okay. So this is just one observation that I want you to make. Maybe they can ask you in MSQ, or it is not like we do not teach in the fashion that they will ask the same question or not. But we are more driven towards the understanding. Understanding should be clear to the function, right? I hope you're getting. Now, suppose, let's suppose that, okay, let's first observe this, and then I will ask you a question. The C, initially, if X less than 0, then it is 0. If X is less than, I mean, greater than 0 and less than 1, which means if I ask you CDF for any number in between this, if I ask you CDF for F0, then you will say it is 1 upon 16. If I ask you CDF for F0.5, you will say it is also 1 upon 16, because it is X less than equal to 0.5, but it's just as F0, which is 1 upon 16. Now, similarly, these are the CDFs. Okay. So let's just understand the CDF in a bit more detail, probably. I mean, I will just give you one intuition using the graph. Let's suppose I draw a graph for PMF first. PMF is what? Probability mass distribution, probability mass function, which means that for every value, it will just tell you that what are the probabilities that it is taking, or what is the distribution of the mass. Okay. Let's just say that it is having some value, maybe -5, maybe this 3, maybe this is 5, this is 10, this is 20. Okay. Let's suppose some values are there. Okay. For a simpler example, these are the 5 values. I'm just saying that probabilities are 1 by 5, 1 by 5, just for the simpler example. Okay. Let's suppose these probabilities are 1 by 5, 1 by 5, 1 by 5. Okay. Just for the simplicity, I'm just saying this is 1 by 5. Now, can you draw CDF? Can you try to draw CDF? So let me just maybe mark these points here only. Okay, this is not the, I mean, the y-axis, but anyway. let me not draw this axis. Okay, let me mark this. This is -5, this is 3, this is 5, this is 10, this is 20. Okay. Now tell me, before -5, what will be the CDF? CDF means that x less than or equal to -5. Let's suppose x less than 5, strictly less than 5. I mean, for this -5. For these points, what will be the CDF? So, I mean, which means, let's suppose if I ask you, what is the CDF of at this point, which means I ask you, what is the CDF of f of 4.9? You will say it is same as p of x less than or equal to 4.9, which is 0, because it is minus 4.9. And this is 0 because less than minus 4.9, it is actually not defined. 4.9 even here, maybe 5.1. Let me write minus 5.1. Anyway, basically at these points, if I ask you at these points, since there is no mass, there is no probability mass, that's why it was 0. Okay, so let me draw the CDF. It was 0 initially till this point. Now at this point, since the PMF is 1.5, that's why the CDF also 1.5. Reason being is that if I just ask you f of -5, f of -5 is p of x less than or equal to -5, and this is same as, there is no other lesser value. This is same as this, which is 1.5. ठीक है, at this point it got 1.5. ये समझ में आ रहा है? Okay. So at this point, this is just 1.5. ठीक है? So I'm drawing the plot of CDF. Maybe let's just see there how it looks. So it was 0, 0, 0. At this point, it was suddenly 1.5. Okay, so 1.5. Now tell me any point in between here. So Akash is saying, can you explain again? See what I'm saying here, that if you take any point here, which is minus 5.1 or something, which is basically the CDF is 0. Reason being is that there is no probability distribution here, right? At this point, at the point which is -5, it will be x less than or equal to -5. I mean, f of -5 is same as x less than or equal to -5, which is x equal to -5, which is 1.5. I mean, you can calculate the CDF very easy. Okay. Now, if I ask you at the point in between, maybe I ask you 2, then what do you think? What is f of 2? F of 2 is f of p of x less than or equal to 2, which means that there is only one possibility. That's why it will be just 1/5, right? This will be 1/5. So which means once it is 1/5, it will be 1/5 till this 3. Okay. So basically it is 1/5 only. Once it is 1/5 till this 3, it is 1/5 only. Now at 3, it will make some jump. Okay. So these are the dotted lines basically. See that this was 0 till this point. Now at -5, it is 1/5, and till this 3, it will be just 1/5. At 3, can you calculate this f3? It will be p of x less than or equal to 3. Can you tell me what is this value? P of x less than or equal to 3. It will be 1/5 plus 1/5. Yes, it will be actually 2/5. So suddenly it will make a jump of 2/5. Okay, it will be 2/5, and then at 5 also it will make a jump, and then at 5 it will be 3/5. Okay, I'm not calculating it again and again, but yeah, at 5 it will make a jump, and it is actually 3/5. Then at 10 it will again make a jump, and then it will be 4/5. And then at 20 it will make a jump, and then it will be actually 5/5. So it is 1/5. Then this gap is actually 1/5. So because we are adding 1/5 at this point. So anyway, like this much detail is not needed, but yeah, this is 2/5, this is 3/5, this is 4/5, this is 5/5. I mean, this is 1. Okay? At one point in time, like if you ask me what is the f of 30, then it is actually probability of x less than or equal to 30, which means it is just 1, because everything is less than or equal to 30, right? I mean, CDF looks like this. It is a step ladder always. For the discrete, at least it is like this. It is a discontinuous function, and it looks like this. It is always increasing function, interestingly, because see, if you are finding f of anything, f of, let's suppose, 3, and if you compare f of 2 and f of 3, then what will be the answer? If you compare between f of 2 and f of 3, which one will be greater? Obviously f of 3 will be greater than equal to f of 2. Reason being is that that f of 3 is having f of 2 plus p of 3. I mean, see, if I compare between f of 2 and f of 3, what is this f of 2? F of 2 is p of 1. Let's suppose only 1, 2, 3 are the only possibilities. 1, 2, 3, 4, 5, 6 like that. And then this is p of 1 plus p of 2 plus p of 3. So basically, this f of 3 is already f of 2. Okay, this already contains f of 2, then plus some jump, which is p of 3. So since this is positive, this is greater than or equal to 0. That's why this is greater than or equal to. Okay, I mean f of 2 is less than or equal to f of 3. So it is always an increasing function because you're adding. So at this point, you're not adding anything. Then suddenly 5 comes, you're adding how much? You're adding, at this point, you're adding p of x equal to 5, basically. Suddenly this 10 comes, you're adding p of x equal to 10. Okay. Suddenly this 20 comes, you're adding p of x equal to 20. I mean, you're adding this some margin. And what is that margin? You're adding that particular mass function. So anyway, like you do not need to understand that much details. Let me even erase this. Should I erase this or not? This jump, otherwise you will get confused. What is this jump and all? I mean, I just told you, but you do not need it. Okay, let's not erase it. Okay. So this is the final like plot you will be getting. समझ में आ गया ना, मतलब ये इंक्रीजिंग फंक्शन है, वेरी इजी. लाइक you will be going flat and the moment there is some probability mass at some point, you will be making a jump. You will be going flat and the moment there is some probability mass at some point, you will be making a jump. The moment you will get some probability mass, you will keep on making a jump, and then finally you will be reaching to 1. This is the upper limit. You cannot reach after 1. Okay. Okay. Now let's solve this. Once again. So now they are saying that let x as a distribution with the function this. So this is a CDF that they have given, where f1, f2, f3, and f4 they have given, and they are asking a different question. Okay, this is a reverse question. They have given you the CDF. They are asking the PMF. Can you find it? So x can take only 4 values. Now tell me, what is this f1? F1 is probability of x less than or equal to 1, which is probability of x equal to 1, which is 0.25. Now, can you tell me what is probability of x equal to 1? I mean, for the PMF, I need 4 values at x, 1, 2, 3, 4, because x can take only 4 values. Do you have this particular value? I think we have 0.25, right? Now tell me what is f2. Can you calculate this value, this value, this value? F2 will be p of 1 plus p of 2. I mean, there are only 2 possible values before this. P of 1 plus p of 2. P of 1 you already know, and f2 is given to you, which is 0.61. So p of 1 you already know, and then p of 2 you can get 0.61 minus 0.25. Okay, that's how you can get p of 2. Now what is f3? So from f3, can you get this p3? Let's just see. See, f3 is basically, you can actually think about it. It is p3 plus f2. Okay, p3 plus f2. Reason being is that, I mean, you are adding something to f2 only. Okay, so you carry the previous one, you add that p of 3 or something like that. I mean, there will be a jump of p of 3 at f2. Okay, so p of 3 you can calculate using f2 and f3. So I think this is coming out to be, can anyone tell me this one? 0.25, 6, and then 5 minus 2, 3, 0.36, right? So this is 0.36, and then you can calculate this. This f2 is given to be 0.61, so 0.83 and 0.36. So you people are getting different answers, and I'm getting different. Is this correct or something is wrong? 7 and 7 minus 3, 4. 0.47. Okay, so here, yeah, this should be 0.61. This is not 36. 0.61, then you are getting 0.22. Okay, this probability 0.22. Similarly, you can get this P4. How you can get this P4? F4 they have given, and then it will be P4 plus F3. Okay, P4 you can calculate using F3 and F4. That is given to you. Okay, so just see here, this is your answers. Are you getting? So basically, this function is an increasing function, and you can, the difference between the two conjugative, which is f1 and f2, it is just a probability of this x equal to 2. Okay, because that was the jump that you had made at 2 when you plot the graph. Actually, these kind of questions, I told you the graph because these kind of questions they might ask in the interviews. Okay, they might say that how does the PDF look, PMF look like, and how does the CDF look like? And then you can say the PMF may look like this, and the CDF will look like always an increasing function, which is a step ladder like this. Okay, they may ask these kind of questions in the interview. That's why I just take care of these kind of things consciously, so that you do not face any problem later also. Okay, so let's solve this question. Consider a random variable x that takes a value +1 and -1 with probability 0.5. The values of the CDF are, okay, they're asking the CDF values. You can do it as a number. This is easy question. You can do it as a number. Okay. CDF value they're asking, and the probability PMF is given. Okay. So given PMF, asking CDF. Cumulative distribution function, which is CDF.